2015, day 16, Aunt Sue. I'd like to send you a thank you card. You've got 500 aunts named Sue. What is the number of the Sue that got you the gift? All right. And what does our puzzle input look? Ooh. Oh, these are all 500 of them. Okay. All right. So what was it? Get input 2015, 16. Input 2015, 16 text. Yeah. Looks good. I should trust my script, right? Okay. So what do we need to do? Avoid sending the card to the wrong person. You need to figure out which can detect a few specific compounds. Children by human DNA age analysis. Cats, it doesn't differentiate individual breeds. Several seemingly random breeds of dogs. Goldfish, no other kinds of fish. Trees, cars, and perfumes. Which is handy since many... All right. Many... You put the wrapping from the gift into the MFC SAM. It beeps inquisitively at you a few times and then prints out the message on the ticker tape. So this data is the same for everyone, right? And it's just our puzzle input which determines which Aunt Sue we're actually going to choose. What's the number of the Sue that got you the gift? All right. So we're basically looking for, oh, but they don't have everything, right? Like this one has just, oh, they each have just 3 entries. So we have to find one that matches all of them. We have limited data. What's a good approach then? Let's start with our usual workflow here, as I like to say. Let's copy this. Change that to 16. Add day 16 here and here and here. And then we run and we get 2 errors. Oh, right. And then I'm going to create this file. 2015, day 16. And okay, we're up and running now. So we need these data, these entries, right? And we also need the puzzle input. So we have 2 things we need to parse now. Although this probably needs to go in our struct. I don't know, how are we going to parse this? So let's take a look at the input file again. And it's just basically a Sue number and then entries for each Sue. So is that just a vec of, we can just create a vec with a hash map inside it? Here's what I'm thinking. So for each Sue, we have, I mean, for all the Sues, we have a vec of a hash map. And the hash map just contains a string and a value. And they're all positive numbers, but let's just throw I32 in there since that's the default for whatever. So then use standard collections hash map. Okay. And then in here, what we'll do is we'll initialize a Sue. So let mod Sue. Oh no, we're gonna. Oh, that's right. We're gonna have to do the comparison mapping, right? So map. Mapping is going to be a hash map as well, and that's going to go string to I32. Right, that's going to contain this info here. So I guess we can just copy paste that and then just convert it over here. So this is mapping equals hash map from, and we just put it in a slice, and that's going to close that out. And now here, oops, yeah, let's just shift this over, and then we can change these to quotes, right? Because we're just going to put a quote in here. And then all these colons change to comma, right? Just like that. And then we just need to, at the end of each line, put that. And that should generate our mapping. And then Sue is just to have vec new. Right? That's all we need for that. So that should work. Let's see if that builds. We have an error. This says 0, 0, but this says 1 error, which probably means I need to restart my Rust analyzer. Yeah, this needs a comma here and that needs a comma there. And mapping. Oh, I guess we can make it a hard code, right? Will that work? Oh, now it needs a lifetime. Okay, so we got to toString all these things. There we go. Okay, and now we're not using things. That's fine. All right, let's restart this thing here. Okay. So now, the parse function is going to read in the file and set up the mapping. I mean the values for Sue. So for line in AOC lib, read lines, input 2015 60.text. What are we going to do? We're going to split the line. Again, let's take a look. Let's do this. Just head input 2015 16. So that's what it looks like. So we can say we can split on the first and last. You know, what we can just use is the index for this -1 shifted by 1, right? So we have a 0 index vector. So Sue1 will be at 0 and so on. So we can just say this data equals line split once on the colon space. And now data should just be, oh, it doesn't like that. I have to unwrap it. Yeah, now it's a stir. Okay. Surprised it didn't put, oh, okay, yeah, fair enough. And then data needs to be split itself by this, maybe comma space. Items equals data split comma space. There we go. And then there's going to be 3 items, but we can make it generic just by saying collect. Like that. Now items is a vec of stir. And now we want to create a new hash map that we're going to insert into the vector of Sue's, right? Let h for hash map. It's hash map new for I in items. So for each item now we're going to split it. We have a name and a count. And that's going to be equal to I dot split once on colon space dot unwrap. Right? And then we just insert that. hm dot insert name, and we're going to parse this out. Count dot parse I32 unwrap. All right. Is that all we need to do? And then part 1, I'm just going to say println. I want to dump it all out here. Debug self.sue. All right, what do we got? We have an empty array. Oh, because I'm not pushing them. Duh. So we do that, and then we say self-sue push hm. Expected struct standard. This is still giving me 0 errors, which is really bothering me now. Cargo clean. All right, let's let that run while we look at this. Expected standard string. Oh, I have to toString it. Oh, I can't do anything while that's there. Okay, there we go. We finally got an error. I have to toString the name. Now we got 3 warnings. That's fine. And let's see what this looks like. It's a little slow. All right. It looks like, so goldfish 9, cars 0, samoyeds 9, and that's what we see. Samoyeds? I don't know how to pronounce that. All right, so now what we need to do is just look, and we should also be able to print out self-mapping, right? Right, and this is the mapping. So that worked as well. So now we just need to compare. In part 1, we just need to compare and look for where they're equal. So we're going to loop over all the Su's. For Su in self Su. Right, self Su. Oh, we have to do iter, right? Do we? No, we can just do this. And then this is that's a hash map. So now what we need to do is look in the mapping for, so key value in mapping, self mapping. Right, that's a string, and that's an I32. So we want to compare now the key. And we want to look up this key in this hash map. So we can say if let some, I don't know, let's just say n is equal to su.get of key. And n is an I32 now. So now it's a reference to an I32. And value is an I32 itself. So, that probably means we're consuming this thing. Yeah. So now we can say if val is equal to n. Oh, then we found one entry. So we want to say if val is not equal to n, then we want to break. Oh, we want to break on outer, right? If we found a value that's not equal to the value we're looking for in the mapping, then we want to go to the next Su in the list. If they all match, then we come here after this for loop and we found the Su, println Su. We didn't get any output? Okay, that's a problem. Do I have to do this? Are we always breaking here? I can start printing out all the values. Println Su matches key equals val. Let's see if we get at least some matches. Oh, we're not seeing anything. We know we're running it because we're seeing this word unsolved. All right, what's going on? This is got to be a Rust thing because the code looks right. Oh, we're only going 1. Wait a minute. Sulan. Self Sulan. Yeah, there's all 500 of there. Why are we only doing 1? Oh, not. Oh, wait. I don't want to break outer. I just want regular break. I want to continue outer. That's it. Okay. My brain is broken. That's the problem. Okay, so let's do that. Oh. I have this one here. I was hoping there would only be a few. Oh, there is only one. Oh, except we don't know which one. Oops. I guess we could just look in the file, but let's have this actually print out the Sioux that it found. So we can do this, self Sioux iterenumerate. Let mut found equals 0. And then for Sioux, we can say which Sioux. And then here we just say found is equal to which, but it's off by 1, right? Plus 1. Found. Nope. Oh, I can't do that. Variable found is assigned to but never used. I have it right here. Oh, because I did it this way. That's why. There we go, 40. So Sioux number 40. Let's take a look in the input. Sioux 40. We have Azalea 0, Cat 7, and Akita 0. And does that match up with this? Azalea 0, Cats 7, and Akita 0. So that matches. And there's only one match, I think, based on what we saw printed out last time. I could always put a break here. Yep. And it's still, although the mapping, oh. Yeah, we don't need to do that. Okay, so it's still 40. So let's see if 40 is the answer here. Ta-da! Okay, that was good. All right. Okay, so that was git status, git add source input, git commit 2015 day 16 part 1. Wow, we're really blasting through these guys, huh? So in later advent of code years, the problems do get harder and harder. These just seem to be pretty much all staying at the same difficulty level, and it's just a question of how to parse it is what makes it difficult. As you're about to send the thank you note, something in the AMP-SCAM's instructions catches your eye. Apparently, is an outdated retro encabulator. Oh, that's from that video about. Oh yeah. It's a YouTube. You can see the link at the bottom there. Where it's just basically it's making fun of marketing materials from 1970s computers. It's pretty funny. And so the output from the machine isn't exact values. Some of them indicate ranges. In particular, the cats and trees readings indicates that there are greater than that many, while the Pomeranians and goldfish readings indicate there are fewer than that many. What's the number of the real Ansu? Oh, okay. So instead of this mapping, well, we want to leave this alone because we still want to be able to solve both parts. What we could do is make an enum, which says, I don't know, we'll call it compare. Some of them are going to be less than, right? So we have a less than. We're still using I32, so let's keep doing that. We have equal to, and we have a greater than. And then what we can do is insert those here. So for children, and then down here, we can just look at the value directly. And then for part 2, we can actually use, because we're still storing the value. Right, so we'll just extract it for part 1, and then part 2 will actually use the enum. So this will be compare : equal to, because this is children. For cats, it's greater than. Greater than 7. This is going to be equal to. Let's put this in a copy paste buffer because I think most of them are going to be that, right? For Pomeranians, this Pomeranians is less than. Akitas is going to be equal to. Visalia is going to be equal to. Goldfish is less, fewer than. Okay, but I put less than. Trees is going to be greater than. And then cars is going to be equal. And perfumes is going to be equal. Oops, I forgot to compare here. Okay. So now this won't build because we're comparing the wrong. Yeah, so this is mapping to a compare. Right. Here's where we're actually comparing compare. So what we can do is we could do a couple of different things. Actually, does this need to still be a star star? I was just doing that when I had it wrong. But that was just from before. Okay, so what I can do is I can say val, because val is the compare and n is an I32. So I can say as I32, right? And then just write a little I32 for enum. Match self, compare less than n, and then we do the same thing here, greater than and then equal to. It doesn't like that. Oh, we need to copy it out, not a problem. And then we do need to put a star there. Okay, and we're still getting 40. All right, so part one is still good. Part two now is basically the same exact code. Except we're going to do a match. Found. Here. Match val. Compare greater than n. And then this is if n is less than or equal to right, our value. Oh, I can't use n again. Should I just shadow val? If val is less than or equal to n, then we want to continue outer. So it means we didn't find the right one. Then we have less than, which means it's greater than or equal to n, and then compare on equal to. And this is the same test as before. Val is equal to, not equal to n. Continue outer. Right? And then we found it, and then whatever. Oops. Oh, okay. So can we compare them this way? 77. Let's see if 77 is the right answer. It's not the right answer. Okay. What did I get wrong? Let's take a look at Sue 77. Goldfish 7, Pomeranians 10, and tree 0. And what are we looking for? Goldfish 7, and goldfish has to be less than 7. Oh, less than 5. Oh, do I have it backwards? I think I have these backwards. I bet you that's the problem. And now it's probably too soon. 241. Let's try 241. 9 seconds left. Okay, I bet you that was the issue, right? Is there a better way we can just compare things? Can I say val compare. And then put all the logic inside the compare. I bet you there's a nifty way to do that in Rust. All right, let's try this again. Okay, that was the right answer. Very good. Yep. All right, that was pretty straightforward too. It got 2 done in less than an hour. Not bad. Shall we continue? Git commit-am 2015 day 16 part 2. All right, very good.